Welcome to 60 Days to Master Python. In this course, you will learn everything from the basics of Python to advanced concepts all within 2 months. Whether you are starting with your programming journey or looking to sharpen your skills, this course is designed for you. Let's dive in. Congratulations on starting your Python learning journey. Over the next 60 days, we will guide you step by step from understanding Python's syntax to building real-world projects. Get ready to learn something exciting each day and apply what you have learned with mini projects. So, what will we learn? In the first 2 weeks, we will cover the fundamentals, Python syntax, loops, functions, and control flow. By week 3, we will dive into object-oriented programming and error handling. Then we will explore advanced topics like web development, data analysis, machine learning, and more. Every week ends with a mini project to help you apply your knowledge in practical ways. This course is designed for beginners, intermediate learners, and anyone interested in taking their Python skills to the next level. If you are new to Python, you will start with the basics. If you are already familiar with some concepts, we will take you deeper into advanced topics like machine learning and web development. Ready to level up? Let's go. Our course is structured with daily lessons that take just 15 to 30 minutes. Every week, we will focus on different Python concepts. You will finish each week with a mini project to help solidify your learning. And by the end, you will complete a capstone project to showcase your skills. Before we start coding, there are just a few things you will need: a computer, internet access, and Python installed on your system. Don't worry, on day 1, we will guide you through the installation process. You just need the motivation to learn and create. Why should you learn Python? Well, it's one of the easiest programming languages to learn with simple and readable syntax. It's also incredibly versatile, used in web development, AI, data science, automation, and much more. Plus, there's a high demand for Python developers in today's job market. By learning Python, you are opening doors to endless opportunities. Excited to begin? On day 1, you will get an introduction to Python, learn what makes it so popular, and set up your environment. Then we will guide you through writing your very first Python program, the classic Hello World. Get ready to write some code. Now that you know what's ahead, let's start coding together. Take it one step at a time and don't worry if you don't get everything perfect right away. Remember, the key is consistency and we will be with you every step of the way. Here's a quote to keep you going. The journey of 1,000 miles begins with a single step. Every line of code you write brings you closer to mastering Python. Stay motivated, trust the process, and remember that every small step counts toward your success. Keep pushing forward. That's it for the introduction. You are all set to start day 1. Don't forget to like, subscribe, and leave any questions or thoughts in the comments below. Let's dive in and start your Python journey today. Welcome to the first day of our Python programming course. Today we will be diving into an introduction to Python, covering its features, installation, environmental setup, and writing your very first Python program. Let's get started. So what exactly is Python? Python is a high-level interpreted programming language that's known for its simplicity and readability. It's a favorite among beginners and experienced developers alike. Some key features of Python include its readable and concise syntax, which makes it easy to learn. It's an interpreted language, meaning your code is executed line by line and it's dynamically typed, so you don't need to declare variable types. Python supports object-oriented programming, making your code more modular and reusable. With a large selection of libraries and frameworks, Python is used in everything from web development to machine learning. Plus, it's cross-platform, meaning it runs on Windows, Mac OS, and Linux. Next, let's look at how to install Python. To get started, visit the official Python website at python.org. Download the latest version of Python 3.x for your operating system and run the installer. Be sure to check the box that says Add Python to Path during the installation process. Once installed, open your terminal or command prompt and then type python version to verify that Python was installed successfully. You should see the version number of Python that was installed. Now let's set up our development environment. An IDE or integrated development environment is a tool that helps you write, test, and debug your code all in one place. For Python, there are several IDEs you can choose from. PyCharm is a full-featured IDE that's great for beginners and advanced users. Visual Studio Code is a lightweight, customizable editor with support for Python through extensions. And if you are working with data science or prefer an interactive environment, Jupyter Notebooks is an excellent choice. To install these IDEs, go to their respective websites. For PyCharm, visit JetBrains' website and download the Community Edition. For Visual Studio Code, go to code.visualstudio.com and install it. Then add the Python extension from the marketplace. If you are using Jupyter Notebooks, you can install it via the command line using pip install notebook. Once installed, launch it by typing Jupyter Notebook in the terminal. Now for the fun part, writing your first Python program. The Hello World program is the traditional first program in any language. It simply displays the message Hello World on the screen. Here's the code: printf Hello World. The print function is a built-in Python function that outputs text to the screen. The text itself, Hello World, is a string and is enclosed in quotation marks. Once you have written the code, it's time to run your program. If you are using an IDE, simply click the Run button. In the terminal, you can run the program by typing python hello_world.py or python 3 hello_world.py depending on your system configuration. Running this program will display Hello World on the screen, confirming that your setup is working correctly. Great job! On day 1, we have covered a lot of ground. You learned what Python is and why it's so popular. You installed Python and set up your development environment, and you wrote and ran your very first Python program, Hello World. In the next lessons, we will build on this foundation and dive deeper into Python programming. Stay tuned. Welcome to day 2 of our Python programming course. Today we will be covering the basics of Python syntax, including variables, data types, and operators. Let's dive right in. Let's begin with variables and data types. In Python, a variable is used to store a value. The great thing about Python is that you don't need to explicitly declare the type of a variable. Python automatically figures it out based on the assigned value. For example, you can create a variable called age and assign it to the value 25, like this. Here, age is an integer, name is a string, and height is a floating point number. Now let's look more closely at the different data types you will encounter in Python. There are a few basic types: integers, floating point numbers, strings, booleans. Integers are whole numbers like 25. Floating point numbers have decimals like 5.6. Strings are sequence of characters enclosed in quotation marks like Alice. Booleans represent logical values, either true or false. Here's an example. Now you have better understanding of how to create and assign values to variables. Next, let's talk about arithmetic operators. These operators are used to perform basic mathematical operations on numbers. The plus operator adds two numbers. The minus operator subtracts one number from another. The asterisk operator multiplies numbers. The divide operator divides numbers and gives a floating point result. The two backward slash operator performs integer division, discarding the decimal. The modulo operator gives the remainder of a division, and as and the two asterisk is used for exponentiation or powers. Here is an example of the basic use of this operator. These operators allow you to perform basic calculations in Python. Moving on to comparison operators. These operators allow you to compare two values and return a Boolean result, either true or false. The double equal to checks if two values are equal. The not equal to checks if they are not equal. Greater than checks if one value is greater than another. Less than checks if one value is less than another. Greater than or equals to checks if a value is greater than or equal to another. Less than or equals to checks if a value is less than or equal to another. These operators are essential for making decisions in your program. Now let's explore logical operators. These are used to combine conditional statements and return a Boolean result. The AND operator returns true if both conditions are true. The OR operator returns true if at least one condition is true. The NOT operator inverts the result, so true becomes false and vice versa. Here's an example. These operators help control the flow of your program based on conditions. Next, let's talk about typecasting. Sometimes you may need to convert one data to another. This is where typecasting comes in. You can use functions like int to convert a value to an integer, float to convert a value to a floating point number, string to convert a value to a string. For example, in the below Python code, x is assigned the value string 25. We can convert this string into an integer by using the int function. Typecasting ensures that your variables are in the right format for your calculations or operations. To summarize, we have learned to summarize what we have learned today, we have covered variables and data types, including integers, floats, strings, and booleans. We have explored arithmetic, comparison, and logical operators. We have also seen how to perform typecasting to convert between data types. Now it's time to practice. Try implementing simple expressions using these operators. Create variables of different types and use them in calculations. This will solidify your understanding of Python syntax and operations. Welcome to day 3 of our Python programming journey. Today we will be diving into control flow and focusing on conditionals. How to make decisions in your Python programs. Conditionals allow us to make decisions based on certain conditions in our programs. They help guide the flow of execution by determining which block of code should run. In Python, we use if, else, and elif statements to control the flow of our program based on conditions. Let's start with the if statement. The if statement is used when we want to execute code only if a particular condition is true. The syntax is simple. You write if followed you write if followed by the condition, then a colon, and finally the block of code you want to execute if the condition holds true. For example, if age is greater than or equal to 18, you could print that the person is an adult. The else statement. Next, we have the else statement. This is paired with an if statement and is used to define what should happen if the if condition is false. In the example here, if the person's age is not 18 or older, the program will print that they are not an adult. The elif statement, in short for else if, comes in handy when you need to check multiple conditions. If the initial if condition is false, Python moves to check the elif condition. You can use as many elif statements as you need. For example, if someone is under 18, they might be classified as a minor, and if they are 18 or above but less than 21, they might have different privileges, like being able to vote but not drink alcohol. Now let's talk about Boolean expressions. A Boolean expression is simply a condition that evaluates to either true or false. For example, x equals to y checks if x is equal to y, while x not equals to y checks if they are not equal. Boolean expressions are also used with logical operators like AND, OR, and NOT to combine conditions. These expressions allow us to create more complex decision-making structures. In this example, we check if both conditions are true using the AND operator. If x is greater than y and also equal to 10, we print a message. Similarly, we use NOT to inverse the Boolean value of the condition. If x is not equal to y, the message is printed. Sometimes you may need to make decisions within decisions. This is called nesting conditionals. In a nested if statement, you place one if statement inside another. For example, if someone is old enough to enter an event, you can further check if they have a ticket. If they do, they can enter. Otherwise, they are told they need a ticket. Now let's combine what we have learned with user input. In this example, we ask the user for their age and check if they are eligible to vote. The input function captures user input as a string, so we need to convert it to an integer using int. Based on the input, the program will print whether the person is eligible to vote. Let's put your skills to the test with a few practice exercises. First, you can create a program to check if a number is even or odd. Second, write a program that checks the temperature and determines if it's hot, cold, or moderate. And lastly, write a program that asks for the user's age and prints which age which age group they belong to. To conclude, conditionals are an essential part of Python programming. Mastering if, elif, and else allows you to write dynamic programs that respond to different situations. Keep practicing writing conditional statements, and soon you will be able to create more interactive and intelligent programs. Thanks for joining me and happy coding. Welcome to day 4 of our Python course. Today we will be covering loops in Python. Loops are a fundamental concept in programming, allowing us to repeat tasks efficiently. Let's dive right in. Loops in Python enable repetitive execution of code, which can save us from writing repetitive instructions. Whether we are iterating over a sequence like a list or repeating actions based on a condition, loops are incredibly powerful. They help to keep our code clean, concise, and efficient. First, let's look at the for loop. This loop is used to iterate over a sequence such as a list, string, or range. Here's the syntax. We use the keyword for followed by a variable name, then that will take each value of the sequence, and then a colon. Inside the loop, we write the code that we want to execute for each item in the sequence. Here's an example of a for loop in action. We have a list of fruits: apple, banana, and cherry. Using a for loop, we iterate through this list, and for each fruit, we print its name. When we run this code, the output will be each fruit printed on a new line: apple, banana, and cherry. Next, let's look at range, a built-in Python function often used in for loops. It generates a sequence of numbers which we can use to loop through a set of number of iterations. The syntax includes three parts: start, stop, and step. By default, the range function starts at 0 and steps by 1, but you can customize it to fit your needs. Here's an example. This, this for loop counts from 1 to 5 using range 1, 6. The loop will print numbers 1, 2, 3, 4, and 5, as we specified that the loop should start at 1 and end before 6. This is a great way to repeat a task a set number repeated task a set number of times. Next, let's explore the while loop. Unlike the for loop, which iterates over a sequence, the while loop continues to execute as long as a specified condition remains true. It's ideal for situations where we don't know the exact number of iterations upfront. As long as the condition is true, the loop keeps running. Here's an example using a while loop. In this case, we start with I equal to 1. As long as I is less than or equal to 5, the loop will print I and increment I by 1 each time. Once I exceeds 5, the loop ends. In Python, we can control the flow of our loops using break and continue statements. The break statement exits the loop entirely, while the continue statement skips the current iteration and proceeds to the next one. These statements are useful when you need to alter the flow of the loop based on certain conditions. Here's an example using the break statement. In this loop, we check if I equals 5, and if so, we break out of the loop. The loop will print 1 through 4, but once it hits 5, it stops early due to the break. On the other hand, the continue statement skips the current iteration and moves to the next one. In this example, when I equals 3, the loop skips printing 3 and moves directly to the next iteration, printing 1, 2, 4, and 5. Now let's talk about nested loops. A nested loop is a loop inside another loop. This is particularly useful when working with multi-dimensional data, like lists of lists. The inner loop will run completely for each iteration of the outer loop. In this example, we have two loops, one for I and one for j. The outer loop iterates over values 1 through 3, and for each value of I, the inner loop iterates over values 1 to 3 as well. The output shows every combination of I and j. In some cases, we may want a loop to run indefinitely until a specific condition is met. This is called an infinite loop. You can use a while true loop, but it's crucial to control the flow with a break statement to avoid getting stuck in the loop forever. Finally, let's wrap up with some practice exercises to reinforce what we have learned today. Try creating a countdown program that prints numbers from 10 to 1 followed by blast off, or implement a guessing number game where the user tries to guess a number between 1 and 20, receiving hints like too high or too low until they guess correctly. This concludes day 4 of our Python course. We have covered the basics of loops in Python, including for loops, while loops, and how to control loop flow using break and continue. In the next session, we will dive deeper into more advanced Python concepts. Thanks for joining and happy coding. Welcome to day 5 of our Python journey. Today we will dive into functions. Functions are essential building blocks in programming that allow us to organize code, improve readability, and reuse logic efficiently. Let's start by understanding how to define a function in Python. The syntax is simpler. You use the keyword def followed by the function name, parenthesis for parameters, and a colon. Then you define the body of the function. Finally, you use return to send a result back to the caller. Functions can also be defined without parameters. Here we have a simple function called greet that does not require any input but prints a welcome message when called. You can use such functions for tasks like displaying information or performing a fixed operation. Now let's look at functions with parameters. Parameters allow us to provide input to function, making it more dynamic. In this example, the function addNumbers takes two numbers and returns their sum. Notice how we pass values when calling the function. Functions don't just execute tasks, they also return values. In the square function, we take a number as input and return its square. The result is then stored in a variable. Using return allows us to send values back from a function to wherever it was called. Did you know that functions can return multiple values? This is done by returning them as a tuple. In the swap function, we return two values b and a, which we unpack into variables x and y. This makes functions more flexible and powerful. Sometimes you may want a function to have default values for parameters. This is where default arguments come in. In the greet function, if no name is provided, it defaults to guest. This can make your function more user-friendly and adaptable. Python also allows keyword arguments where you specify the name of the parameter when calling the function. This improves readability and ensures that the arguments are passed correctly. For example, we are using introduce with name and age specified by their names. With variable length arguments, Python provides even more flexibility. Using *args, you can pass a variable number of non-keyword arguments. Similarly, *kwargs lets you pass a variable number of keywords arguments. This is perfect for situations where you don't know how many arguments might be passed to your function. Let's talk about the scope of variables in functions. Local variables are defined inside a function and aren't accessible outside. However, global variables are defined outside of any function and can be accessed by any part of your program. Keep this in mind when designing your code. Recursion is an advanced concept where a function calls itself to solve a problem. In this example, the factorial function calls itself until it reaches the base condition. Recursion is a powerful tool, but make sure you define a base case to avoid infinite loops. Now that we have covered functions in depth, it's time for some practice. Try writing a function to calculate the factorial of a number using recursion, or create a function that takes a list and returns the highest number. These exercises will help reinforce the concepts you have learned today. To further sharpen your skills, consider creating a mini project. For example, build a calculator with different functions for operations like addition and subtraction, or create a number guessing game where functions help structure the game logic. These projects will give you hands-on experience with everything you have learned about functions. That's it for today's lesson on functions in Python. Functions are a core part of programming, and mastering them a more efficient will help you a more efficient and organized product. Keep practicing and we will see you in the next lesson. Welcome to day 6 of our Python programming course. Today we will explore Python's powerful built-in data structure. By the end of this lesson, you will understand how to efficiently store and manipulate collections of data. Let's dive in. First up, we have lists. A list in Python is an ordered collection of items. Lists are mutable, meaning you can change their content. For example, we can create a list like this. Lists are great for storing data that you need to access and modify regularly. Let's look at some common operations on lists. You can access elements using an index like mylist0, which gives you the first element. You can also modify elements. For example, mylist2 is equals to 10 will change the third item in the list. To add new items, you can use the append method, and to remove an item, use remove. You can also use pop to remove the last item. When working with lists, you can loop through the items with a for loop. Here's an example. For item in my list, print item, and for slicing, you can grab a portion of the list like this. Sublist equals to mylist 1:4. This returns a new list with items from 1 to 3. Next, let's talk about tuples. A tuple is also an ordered collection, but unlike lists, tuples are immutable. This means once a tuple is created, you cannot change its content. Here's an example of tuple. My tuple is equals to 1, 2, 3, 4, and 5. Tuples are useful when you need a collection of data that should not be modified. Similar to lists, you can access elements in a tuple with an index. However, since tuples are immutable, you can't modify or add new items, but you can slice a tuple like so. In the example, subtuple equals to my tuple 1:3. This will give you a portion of the tuple without changing the original. Now let's look at sets. A set is an unordered collection of unique items. If you try to add duplicate elements, they will automatically be ignored. Here's an example of a set. Sets are great when you need to store a collection of items and don't care about the order, but you want to avoid duplicates. With sets, you can add elements using the add method and remove them with a remove or discard. You can also perform set operations like union, intersection, and difference. For example, to combine two sets, you can use the pipe operator like this. Union equals to my set, pipe, another set. To iterate over a set, you can use a simple for loop. For item in my set, print item. This allows you to loop through each element in the set. Finally, let's talk about dictionaries. A dictionary is an unordered collection of key value pairs. It's useful when you need to associate with a unique key with a value. Here's an example. You can store various types of data using dictionaries, and they are especially powerful for looking up values based on a key. In a dictionary, you can access values by referring to their keys like this. Name equals to my dictionary name. You can also modify values, add new key value pairs, and remove items using tail. Dictionaries have several useful methods like dot keys, dot values, and dot items. You can use these methods to access the keys, values, or both from a dictionary. For example, in the Python code below, for key, value in my dictionary, print key, value. Let's now look at some practical examples. For lists, you can create a simple to-do list like this. To-do list equals to buy groceries, write homework, clean the house. To-do list dot append read a book, print to-do list. For tuples, let's say you are storing geographic coordinates. Here's an example. This tuple represents the latitude and longitude of New York City. For sets, you can use them to remove duplicates from a list. Here's an example. The set will automatically discard the duplicate values. And for dictionaries, let's say you are storing student grades. This allows you to easily manage and retrieve data associated with each student. To summarize, today we have covered Python's fundamental data structures like lists, tuples, sets, and dictionaries. Each data structure has its unique characteristics and use cases. Lists are mutable, tuples are immutable, sets store unique items, and dictionaries store key value pairs. Mastering these will make it easier to work with data in Python. Welcome to day 7 of our Python course. Today we will focus on practice session where we apply what we have learned so far. We will be working on two mini projects, a basic calculator and a number guessing game. These projects will help reinforce key concepts like functions, loops, conditionals, and user input. Our first mini project is a basic calculator. The goal is to create a program that performs basic arithmetic operations like addition, subtraction, multiplication, and division. You will need to write separate functions for each operation and use loops to allow users to perform multiple calculations. You will also need conditionals to choose the correct operation and handle errors, such as division by 0. Users will input numbers and choose the operation they want to perform. Here's the basic workflow of our calculator. First, display the available operations, addition, subtraction, multiplication, and division. Then ask the user to input two numbers. Based on the user's choice, you will perform the selected operation and display the result. Finally, prompt the user if they want to continue with another calculation or exit the program. Here's an example of how you can write the code for the calculator. The program defines functions for each operation: add, subtract, multiply, and divide. Inside the main loop, the user can select an operation, input two numbers, and see the result. If the user chooses to divide by 0, we handle that error and display a message. Now let's move on to our second mini project, a number guessing game. In this game, the computer randomly selects a number between 1 and 100, and the user has to guess it. After each guess, the program will tell the user if their guess is too high, too low, or correct. This project is a great way to practice using loops and conditionals. The workflow for the number guessing game is simple. First, the program randomly selects a number between 1 and 100. Then the user enters a guess. After each guess, the program checks whether the guess is too low, too high, or correct. The loop continues until the user guesses the correct number. Here's an example of the code for the number guessing game. We use Python's random module to generate the secret number. A while loop repeatedly asks the user for their guess, providing feedback after each guess. When the correct number is guessed, the game ends and the program congratulates the user. Here are some additional considerations. You can customize the calculator by adding more advanced operations like square roots or exponentiation. Similarly, for the number guessing game, you could increase the range of numbers, for example, allowing the user to guess between 1 and 1000. Good programming practices like using functions to organize your code and handling edge cases such as invalid inputs are key to creating a clean and effective program. By the end of these projects, you should have reinforced key concepts like functions, conditionals, loops, and user input. You will also have gained practical experience in building a simple Python program. These skills will serve as a foundation for more advanced projects as we move forward in this course. Great job! You have now completed the practical session for day 7. These mini projects will help you become more comfortable with Python and prepare you for more complex tasks in the future. Keep practicing and see you in the next session.